Before I begin, I just want to thank the track chair for the introduction and Unity for masterminding the invitation to talk today. I'm Will, and I'm creative and studio director at Sugar, as well as co-owner and innovation lead at Fictioneers. Originally a molecular geneticist, I moved into design and then into immersive development. Common thread through this is my fascination with innovation, the way in which it enables us to pursue and explore new ways of communicating. Sugar Creative is an independent agency combining skills in design, immersive technologies, and development to provide varied projects for brands and organizations worldwide. This encompasses experience design, front to back end coding, and Unity engine development. One of the major things we do in this space is that we create industry-leading, cutting-edge AR, VR, and MR experiences. Amongst our recent projects, on which I'm focusing on today, is the creation of Dr. Seuss's ABC AR app. Dr. Seuss's ABC AR is a brand new type of XR-driven experience that combines play with learning to make the magical imagination of Dr. Seuss come to life. In this experience, you move through the book, listening to the iconic rhymes, learning the letters through physically drawing them, and interacting with the amazing characters, all in the room right in front of you. Another of our recent projects, which I'll be mentioning today, is the soon-to-be-released Wallace and Gromit, The Big Fix-Up. Delivered as a collaborative piece under our joint venture on Fictioneers, funded by the UK government, and in collaboration with Tiny Rebel Games and Potato. It is designed in part to act as a demonstrator for the potential of storytelling that harnesses emerging immersive technologies. It's a new epic adventure co-authored with the legendary Augmented team, where the users will be able to experience and interact with the story, helping out Wallace as it unfolds over time using a combination of traditional and immersive elements. I'm going to be focusing on these projects in particular today, as, thanks to the direct support of the incredible team at Unity, the realization of them has been powered by Mars. For Sugar, Mars has been the toolkit that has allowed us to realize a new horizon and a shift in the potential of immersive experiences by enabling them to become truly dynamic. Put simply, we see Mars as adding intelligence to AR. To demonstrate just how powerful, interesting, and plain fun this has proven to be for us, I'm going to show how some of the features Unity went through in their keynote have let us build AR like never before. Some of the bits that I'm going to show have clips of features in use in the real world, while some are in engine to give a bit of an insight on how we've put them together. In the first instance, Mars provided intelligence to the AR in the form of conditional logic and reasoning APIs. The very dry when looked at in isolation is the first step in creating real and fun environments. It is what enabled us to create virtual content that is genuinely based on aspects of the real world. We're able to ask, is what is being looked at a floor, a wall, a table, or so on? This lets us create in a way that is based on the nature of those real world elements. Is a surface big enough? What is a plane's height from the ground? And what can't I see? Within the projects, this has enabled us to make sure that some of the grass that we spawn is on the floor and not the table or a wall. And it makes sure that apples or water fall down onto that floor. It's a simple thing, but it's a prerequisite for immersion. We also harness Mars to provide intelligence to the content itself, allowing behavior to be defined both by its relative alignment with the real world and by its relative position in that world. For example, when spawning content onto a wall, we are able to make sure that a picture is stuck to it whilst the tentacle emerges from it. When spawning these things, we are now able to make sure that they automatically place themselves in a natural and logical position. For example, the fireplace in Dr. Seuss's ABC AR locates itself against a wall by harnessing a combination of several property forces. The ability to move itself, the ability to assess plane size, the ability to assess alignment, and the ability to define its route to a desired position. It does this by recognizing both where it is on a floor, then by looking for where the most suitable wall is in relation to it. Lastly, it looks at that wall and identifies the most logical spot to place itself. In our case, as a fireplace, this is with its back against the wall and approximately in the middle of it. Once this is resolved, it adjusts its position accordingly. Mars has also enabled us to power intelligent behavior in the AR characters. You saw in the keynote that through the real-time creation of evolving nav mesh, we've been able to give characters an AI system that allows them to move organically through the real world. It does this by constructing a nav mesh in real time, as And as more planes are scanned, checking the relative depth of those planes and combining them into a single walkable, navigatable surface where appropriate. It also lets us know where the gaps are and how to move between them. Not only are you able to direct characters to move, but when doing so, they're able to know if they're moving between surfaces or even if they are encountering objects, such as a virtual apple or a real-world table leg. These are objects that would distract them or cause them to move around it. This in turn lets us move away from a dedicated play space, creating a sense of imagination made real more than ever before. It also creates a greater sense of these characters not just being an extension of your will, but when they interact independently, of having a separate agency. The team also used Mars to power the intelligent interpretation of depth and plane data to build a picture of the real world, in turn allowing for dynamic occlusion. With more localized occlusion, as in the clip on the right, we achieve this by combining vertical and alignment data with the masking that is generated at runtime. With occlusion at building scale, as in the clip on the left, this was done by comparing depth data with a known value and locating a pre-generated mesh onto the real world. Twinning in this way lets us create virtual to real-world interactions of an unprecedented scale and scope. Overall, this occlusion is yet another step towards more realism, creating an immersion for users into an imagined world. These projects have also allowed us to see firsthand that Mars has the power to enhance the way in which Unity gives AR intelligence through the ability to integrate external APIs. This will underpin a soon enhancement to one of our projects, where the time of day will affect the environment that is created and the behavior of the characters within it. In the evening, the playtime will shift to a slower pace, and at night, the characters will fall asleep, all to encourage positive use behaviors for children that are playing the app. In the big fix-up, it is Cloud Anchor APIs that power the geolocated AR and drive play through environmental exploration. When looking at the potential of Mars, we are streamlining and enhancing this with direct in-engine integration, an exciting potential at both a creative and a development level. The clip on the right, you can see how API integration powers the speech recognition inside another project we created recently. This assists in the identification and diagnosis of degenerative neurological conditions through the analysis of voice commands that are given in the real world but to an AR virtual pet. Whilst all these integrations are something that was possible within Unity, the simplicity of this integration within Mars has increased the flexibility with which we're able to apply the data, and in turn allows us greater creative freedom. Individually, these elements offer an awesome toolkit. Collectively, they have enabled us to go beyond place content into the creation of playful authored spaces. Reacting to the unique environments of the player space, we're able to move away from controlling a play area into something that builds based upon predefined constraints. These constraints define a logic in the way in which AR elements interact and are spawned, ensuring that no matter what the user scans, the design gameplay is still viable. The user has freedom, but we as designers define an architecture for that experience. These constraints ask to author and allow for control of AR content in a much more subtle way. Subtle author control like this makes the whole experience feel much more organic for the player. Overall, this flexibility lets us create systems that we can guide play with, systems which, for the user, create content that feels as if it grows magically from their environment, as if from their imagination. All this in turn lets us author a different type of narrative, one that's rigid, but one which is explorative. This idea is central to the big fix-up, in which, for the first time ever, in a Wallace and Gromit story, the user is both participant and passenger in a narrative journey, making choices that affect their path through an experience of a story that shares common beats for all those who take part. Exploration in this way reflects the real world as never before. When talking about common experiences, from anything from as banal as getting a cup of coffee to as adventurous as running through a jungle, we recognize that though similar each time and critically each person's experience of these things would be unique. This is something that is at the heart of how we think as humans, a shared overlapping way in which we understand what we see and do in terms of story. The ability not to harness this core shared humanity, but embrace individual perception and choices, creates new narrative methodology, a narrative methodology by which we are able to create new types of stories. Emergent stories that break down the barriers between the real and the imagined. With future projects, we are looking to embrace this and create an evolving dynamic link between environment, content, and choices, harnessing the potential of these new types of AR content. This will let the player guide the player elements and build their own unique version of a narrative, which still shifts as they experience it. This hybrid agency-driven emergent storytelling offers a new frontier in experience creation for AR. All these new potentials come with new and unique design challenges. I'm 100% certain that the majority of these new challenges are ones we've not even begun to consider. However, I am sure that exploring and building these will continue to be an amazingly exciting thing to evolve for. There are obviously a load of development features designed to optimize production inside Mars. But the thing that we found most cool is the way in which we were able to chase down and resolve unexpected behaviors with a comparison tool. Once we had defined an authored space, the simulation views one-click checking of plane parameters let us visually debug the logic that underpinned the object behavior. For example, not just knowing if an object, be it robot trousers, a tuttle tree, or a lamp, had failed to spawn, but the parameters on the plane in which we had expected to, let us refine behavior in real time. Rapid debugging and the ability to sanity check what we saw as we went along was a huge shift in mid-stage development for us, and one that not just saved time, but removed huge amounts of frustration. The use of Mars has, for us, marked a shift in what we've been able to realize in AR, as profound as the shift moving from 2D to 3D. Our experiences using this have been such that all apps we create going forward will look to utilize elements of the Mars toolkit. For us, Mars is that missing piece, not an AR gimmick, but something that we see as the cornerstone of the future of AR development. I'm aware that I sound like a Unity fanboy at this point, but what Mars has done is trigger the entire team here to be extremely excited about what we can make with it. For us, this new AR will definitely include a range of cool collaborations and projects. We are currently developing a multi-user experience that draws on the functionality of Mars and combines it with shared AR anchor data to enable you not just to play freely, but to do it with friends. We are also in the midst of creating an AR experience based on dynamic real-world physics and an XR portal that will take you back in time. As well as that, we're going to be deploying an exciting update to the Dr. Seuss app in a couple of days that incorporates more of the dynamic environmental reactive features I mentioned earlier. I'm aware that I've raced through a lot of complex stuff, and if I've done it right, you should have a range of questions and ideas of your own. There'll be a short Q&A in a sec, but to go along with this, I'm going to be running a deep dive live stream in a couple of weeks with some of Sugar's on the team and some of the Mars team, in which we'll go into more detail about both the projects and the use of Mars. If you'd like to join us for that, just send a message via the email on the screen and we'll send you an invite. Thanks for listening. Happy to move on to some questions now.
So the first question that we have is, what version of Unity does Mars require?
Phil, it's probably easier if you grab that from a Unity angle.
Yeah, so Mars supports 2019.3, and we'll be quickly rolling out support for 20.1 when that comes online.
Perfect. And then as a couple more questions pop in here, I'm just curious that when developing a narrative the way that you are, the UI, I imagine, is a challenge, right? You have to find some way of folding this into the story. And so for those of us who are kind of new to that, what are some of the challenges that we can expect to face and maybe overcome?
A lot of this is down to the fact that it is completely new and different. You don't have a playbook to run off. And equally, that does mean that you don't have anything which is perceived to be right or wrong. So fundamentally for us, it is expect for testing. Test continuously, get as much playtest in as possible, put it in as many hands as possible. Just to kind of break up these questions just for a second, one of the things that was cut off at the end of the talk was the fact that we're going to be running a dedicated deep dive session into a lot of this content, where we're going to dive into exactly how it was built. And if you want to join that, just send us an email at deepdive@sugarcs.com, and we'll add you in. There's going to be some of our development team from Sugar, some development team from the Big Fix Up, and some of the development team from Unity as well are going to join us. So that's going to cover a lot of the questions. That was one of the key bits that was cut off at the end.
And forgive me if I missed it. And when will that be?
That's going to be in a few weeks' time.
Okay, fantastic. And then is Marge an add-on package? Looks like was a question that popped up.
It's not so much an add-on as a component within.
Okay.
Did you want to?
Yeah, so Mars will be marketed as an add-on to Unity. So we'll have more details for you on June 1st, on Monday, when we go live.
Yeah, we have
fantastic.
The advantage of Unity supplying us an early development mode, so.
Yep. And then just real quick, it looks like there's some interest popping up on the chat there. So what is the email again? And then just in closing, how can people get a hold of you to follow your work and what's going on?
Yeah, the easiest way to do it is either reach out to me directly or to email will@sugarcs.com, or for the deep dive@sugarcs.com.
Fantastic. It looks like some people put it in there for the deep dive. And then what are some exciting things that you're looking forward to this year, hopefully, with some of the announcements being made and some of the things that you're working on?
Yeah, multiplayer AR builds on the real world. The massive building scale occlusion, multiplayer stuff. Essentially, just the ability to have giant squid-like things appear over the top of buildings that you have to combat is just a thing that makes me really quite excited for the potential of what we can do.
Awesome. Well, thank you so much, gentlemen, for your time, and thank you very much, Will, for your presentation. So a round of applause, and please everyone on the chat as well. Drop these folks some emoticons for the good work that they're doing, and we'll see your work throughout the year. So don't forget to join those folks for the deep dive at sugarcs.com. I know I'll definitely join. Looks like it's going to be some good stuff. And moving on to our next